afternoon to all. Today we will continue with the unit 3. So in the last class we initiated unit 3, and under which we done with the characteristics of an embedded systems. Today we will look into the next topic. I hope my screen is visible. Okay. Now, quality attributes of an embedded systems. Coming to this, what do you mean by attribute basically? What do you mean by attribute? It's once again the dictionary meaning of attribute is nothing but characteristics of an entity, we call characteristics, to be more clear. And local language or an regional language, we call them as gunalakshanagalu. Quality attributes, gunamattada gunalakshanagalu, operational quality attributes. So which means when you consider any of the embedded system, or whenever we try to design an embedded system, the design should take into consideration of both the functional and the non-functional aspects. Now what is this functional aspects and non-functional aspects? Which means now I'm using this mobile phone. So whenever I try to open the apps, or whenever I try to use the applications from my mobile phones, then that's what the functional operations, functional aspects we call it as. Now when I don't use what non-functional attributes or non-functional aspects are those wherein most probably I will be not using in terms of function, which means I'm not giving the job to processor, but is it a handy device, or is the embedded system will give me a longer time durability of that particular system. That's what we call it as non-functional aspects. Similarly, that's what if it is operational, then we call it as a functional aspects. Then one more, we have non-operational, which is nothing but non-functional, whenever the embedded system is not functioning, okay, and its quality attributes. So embedded systems during the quality attributes during operational and during non-operational. Okay, so these are the few important attributes that we are going to deal with today's class. So mainly, once again, more clearly, you need to understand that the quality attributes are nothing but the characteristics. So again, to be precise, gunalakshanagalu. What type of gunalakshana? Gunamattada gunalakshanagalu. So again, when it comes to the operational, this one, so maybe the system response is one of the embedded system response is one of the quality attribute. Output, which means efficiency of the, when we talk about the efficiency of the system, it is nothing but throughput of the system. And durability or reliability or trust, that's the third important quality attribute we will see in the class. Then maintainability, security and safety. These 6 are the important operational quality attributes, we call it as. So you can remember that RTRMSS. So most important question you may get, explain the quality attributes of embedded system. You are supposed to explain both operational and non-operational quality attributes. Then coming to non-operational, which are the non-operational quality attributes? So that is, as I told you, that testability and debugging ability, availability, portability, time to prototype and market, per unit total cost. These are the non-operational quality attributes of any of the embedded system. Now, in this class, we'll go through a detailed uh, analysis or detailed explanation of individual quality attributes both in operational and non-operational mode. Now coming to topic, first topic of operational quality attributes. So what is this? Response. What do you mean by response? The figure itself indicates it's more of how fast, how quick your embedded system is. So response is nothing but it is a measure of quickness of the system. So more importantly, it gives an idea about how fast your system is tracking the changes in the input variable. So you have a system. So how fast the system is so here, how fast the system is responsible based on the output is based on the input, sensed input, how fast the output is going to be occurring across the output port. So that's what talk about the response of the system. Whenever we design the embedded system, we should be much more having an awareness towards the response of the system. Okay, so next important point. So okay, once again, this response may be a real-time approach or may not be a real-time approach. What do you mean by this response with maybe real-time or non-real-time? So considering one beautiful example of the toy car. Okay, the consider embedded system, one toy car. So where now I try to give a key, a small key, I try to press it, or I will be having a remote controlled toy car here. I press within the remote a start button, then the car may immediately start, or it may take a few seconds of time to start and to get moved for a certain distance. And again, when I take a turn, whenever there is a wall as an edge, or a consider there is a wall as an edge or a obstacle detector, so I try to take it before it hits, but sometimes it's not so, it will hit to the wall, because there is a the response is not as fast as the consider the to be a real time, right? So okay, nothing wrong in such a situation, because anyways it is a toy car. There is no such kind of real time that is happening over there. This is ultimately we are using the toy cars for fun. Now the same case is not true with your the deployment of airbag, right? The here the response should be very quick, and it has to take very less amount of time. So that's what the example, an embedded system deployed in a flight control is one of the example for real-time response. And another response I told you about the uh, airbag deployment. So another good example for non-real-time response is the electronic toy car, which is certainly not at all a time critical, whereas in case of this here it's a time critical situation. So this is a first important uh, quality of an this should consist for any of the embedded system that we design, right? So that is response is very important. The response may be quick, the response must be quick, and the response should be very fast. And yes, of course, based on your application, the response may be real time or non-real time. Okay, now the second quality attribute, it is throughput. What do you mean by throughput? It always talk about efficiency of the system. It always talk about it is in terms of, it is measured in terms of benchmark. So when I consider, let me give a very good analogy of the benchmark. So the best example is right now the number of students got placed in our college is almost 400 students across all the branches, considering all the branches, right from E&C to mechanical engineering. And now 400 is the benchmark for us. For the next year, for your batch, we should cross that. So that is what the improvement in the efficiency, improvement in the numbers gives me the efficiency, right? So that's where generally the throughput always talk about the measured in terms of benchmark. And so you can see here it is always going to be the efficiency, how fast or how best you perform. So that's where the embedded system must give a higher efficiency. What do you mean by higher efficiency? It is nothing but the rate of production or operation defined process over a stated period of time. Now it is something like I'm the embedded system. See, for example, I have an embedded system which went let me take GRB GI. I think you might have saw this wonderful ad where automatically there it tried to fill up the bottles continuously. The bottle will be filled up automatically. It stops if the bottle take for example 200 ml, then soon after it reaches 200 ml, the key falling into the bottle will going to stop, and it push it to the next stage, and new bottle, empty bottle will come into this place, and then again it starts filling up automatically. All these things it is done automatically. Now how fast, what is the efficiency of this embedded system, so that how many bottles it is going to be covered in 1 hour. So that is going to talk about the efficiency of the system, right? So obviously it should be more than a manual people that we try to fill it, right? So that's what we rate of production or operation that is going to be defined over a process. The process here in this example is considering as a filling up of ghee to a bottle measuring of 200 ml, right? So this is what we call it as the efficiency or throughput of the embedded system. So next important point, whenever we design embedded systems, the another important point that must be there in our mind, it is throughput. So throughput talks about the efficiency, it sets the benchmark, and it always gives the higher the benchmark, higher the efficiency. That's it. So next, the third important another quality attribute of an embedded system under operational quality attributes. Once again, all these are whenever a system or embedded system is in operation mode, right? So when I talked about the response of the system, so which means that the response of the system is measured while the embedded system is in operation. So I cannot consider when the vehicle is stop, I cannot consider the response of an airbag, right? It means that the vehicle should be in a moving, then the system is already should monitor that vehicle, then now such scenario we call it as a operational quality attribute, right? Now third one is reliability. What do you mean by reliability? It's nothing but reliance, trust, right? Confidence, that is trying to give it for a customer, right? What is the meaning? Which means that it is a measure of how much percentage that one can rely upon a proper functioning of a system, or what is the percentage of susceptibility of the systems of the to the failures. So which means that as I gave you one the previous example of the automatic machine for filling up of the ghee to the bottles, or GRP example. Now again, this again for how much percentage, what is the susceptibility of the failure, that gives me the reliability, which means that after running 100 hours of time, or in a day, if I run a continuously 12 hours of time, should I shut it down? Or if the after running for continuously 100 or 200 hours the system goes to the failure, is that the case? So that's what the susceptibility talks about, when the system get into failure, when it may fail in its the production. So that's where we talk about, and we must be careful. If I designed a system where it after filling up of 100 bottles, if the system becomes failure, if it won't perform, then is it a good quality, or is that a good quality attribute of an embedded system? Definitely not, right? So whenever I design any of the embedded system, it must give a reliability. Same thing is true with whenever I buy a washing machine. It's also one of the very quality attribute system, embedded system. So obviously I expect the higher percentage of proper functioning, right? Here and there minor repairs will occur, but that's not the issue here. But it should not so happen like I bought one washing machine, and again after 5 years or 2 3 years system went for the failure, and if it doesn't perform, if the algorithm scores fail, and definitely it's not a good reliable one, right? So always when the customer always looks for a good reliable, and this is very important in the shoulders of embedded system engineers. Okay, now another important point here, how do you measure the reliability? Reliability is going to be measured with the two important factors, that is mean time between failures. What is the mean time? Well, it is nothing but what is the average time between the failures, and what is the average time for getting it to repair. So that is mean time between failure, MTBF, and mean time to repair, MTTER, are the two terms that is used and defining the system reliability. And based on this, okay, we talk about the whether the system is reliable of 80% or whether it is reliable for only 50%. So that's how the reliability is going to be measured based on the MTBF and MTTR. Now most of the times MTBF gives the failures in hours or weeks or months, which means that if the system, if before it failures, say for example I bought a washing machine for 4 years, for 4 years it will be working fine. After 4 years there will be a small there is a small type of errors may occur, and it may go for repair here and there. So that's what now the MTBF time for washing machine is 4 years. Okay, now if it takes 2 weeks to get repair, then I call it as mean time to repair. Okay, now later on we have one formula of availability for working condition, that we will take it in as a one example. We'll also discuss that particular point here. Okay, no doubt. Next, what about MTTR? MTTR specifies that how long the system is allowed to be out of order. So that's what I told you. If my washing machine fails, then how long it takes for get repaired. Which is other way I can say the sentence like how long the system is allowed to be in out of order mode. Okay, so that's where we these two are the important terminologies when compared to reliability. Make sure that whenever you try to write the reliability concept, you should not forget to mention these two important concepts. Now, okay, so maintainability, we have a systematic equation for that to support and maintenance for the end user. Basically, before it comes, so always the product failure or routine checkup system, what we say that. So it has to be calculated before coming to the market, and that we try to uh, calculate here. So once again, maintainability is the fourth important point. Once again, in case of quality attribute, right? So quality attribute, what do you mean by maintainability and reliability? These two are complementing to each other, right? Okay, which means that if the system is reliable, then there is a less maintenance. If the if it is not so reliable, then maintenance is bit high, right? We always call whenever we buy a car, then what is the maintenance of that particular car, right? Because when I buy the car, always for every 10,000 kilometers or 12 months I drive my vehicle, I should leave it for service. So that's what we call it as a maintenance, changing the oil and changing the brake oil, right? Sometimes after running for 40 kilometers as such, or 30 kilometers as such, I need to change all the four tires of my vehicle. So that's how if I call that as a embedded system, if a system, then all these things call it as a maintenance of that particular vehicle, right? So certainly, if there is a if the same thing is true, there will be small embedded systems. It will be involved in your vehicle. Say for example, rain sensor wipers. Whenever the drop appears on your glass, automatically wiper turn on to wipe off the waters placed on the glass. So in such cases, there will be small embedded system designed so that to sense the water and to perform it. Probably for every 4 years or 2 years after, sometimes it will not work. So that's what we call it as the rest less reliable. They are all very small minor features of the embedded systems, right? So these are the few important points that you are supposed to understand, and make sure that you try to give the clear difference between reliability and maintainability. Once again, these maintainability can be classified into two important classification, namely, one is scheduled or periodic maintenance, we call it as that is preventive maintenance, and second one is maintenance due to unexpected failures. Now, periodic maintenance means what? Taking the example of your printer, for every 400 pages that you, sorry, 2000 pages that you print, after that the ink in the cartridge will go over and you need to replace that cartridge. Now this is the periodic maintenance, I call it as, right? After every 1 year of a vehicle that you drive, then probably you need to change the oil. So that is what we call it as a periodic maintenance, right? So same case in case of embedded systems. Taking a printer as an example, you need to replace the cartridge for based on your usage. Probably maximum it will give 2000 to 2500 number of page printouts. Same thing. Now, another example for maintenance due to unexpected failures. Probably this is very good example where I can consider. See, whenever I keep the paper, then automatically there will be one small sensor present in the printer that will going to sense the presence of paper, it is present or not. Then probably sometimes that sensors go wrong, which means due to usage, due to the aging of the device, probably it loses its sense. So however, in such cases we call it as an unexpected failures. We will be not knowing when the sensor stops working, right? So definitely we will be knowing when the cartridge stops working after maybe 2000 or another 500 papers, that's it. But this we don't know when it stops. So that's what we call it as an unexpected failure or corrective maintenance. Either preventive maintenance because it's already known, so we can make sure that after 2 days or 3 days definitely I need to bring the cartridge. But here it is not so, right? This is a difference between maintainability and reliability, and one of the very important formula that is where in any embedded systems the ideal value for availability. What is availability? What is availability? Availability is nothing but MTBF, where MTBF stands for mean time between failures divided by sum of mean time between failure and mean time to repair, which is nothing but how long you can keep your device in a out of order. Okay. Now ultimately, maintainability is an indication of availability of the product, that is for usage. So this is, how much time or how much time I can able to use this device, any embedded system that you use. That's what it is called as. That's what the meaning of the maintainability or the this particular formula AI, availability of the ideal condition. Okay, at the end I will try to see one good example. Note down this formula, and I have one question on this for you guys at the end of this class. Now, moving further, the fifth important, the quality attribute of the embedded system, and where the design should take care, is all about security. What do you mean by security here? It's nothing but no, and most of the times okay, I'll explain that but later on. But security is nothing but a confidentiality or integrity or availability. Don't confuse this availability with a term that is mentioned in the previous slide. Okay, that the mentioned under maintainability is different than here. Okay, now these are the three important points with respect to security. What do you mean by confidentiality? See, when I design a system and it has the main important job of that system, it has to protect the data and application from unauthorized disclosure, right? Unauthorized persons disclosure. It has to protect my confidentiality, right? That is what the first security. Even every mobile will have this option, right? Now, integrity. What do you mean by integrity? The again, it is a protection of data. See here, all the three important points concerned with security is to protect the data and application, the confidentiality from unauthorized disclosure, integrity from unauthorized modification. So if any other person tried to enter into my Gmail account and he tried to modify this data, so that's what we call it as, that should not happen. So that's what we call it as integrity. And availability, so protection of your data and application from unauthorized users. Okay, very straight equation. There is no much complexity involved in understanding this concept. I hope so. Here probably you understand this concept very well now. So now the next and the last important point with respect to operational quality attributes is safety. So, and once again, not to confuse with these two terminologies, safety and security. Okay, security in perspective of maintaining or giving the security for your data and application. But whereas safety deals with that physical damage that happens to your embedded systems. Okay, in such cases, which means that due to a radioactive device hazards or any the emission of the radioactive materials, the device should not break down. Okay, that's what the kind of safety that we try to give it for your uh, embedded systems. Say for example, you if anything knowingly or unknowingly, if accident happens, and there are a few embedded systems that is present in your vehicle. So all the if assume that if all the embedded system, all the MCUs starts not working, then what should I do? I should invest a huge amount to get it repaired. So for a small accident that happens, so that should not happen, right? Due to a sudden change in the environment or due to sudden breakdown because of a unconditional weather or as such, so the device should be fine. Okay, it should withstand some the benchmark thing here. So so breakdown of an embedded system may occur due to a hardware failure also, or firmware you can consider it to be a software failure also, right? So even we need to provide the security of the safety for the hardware systems so that it will not get failure due to hardware failure or firmware failure. These are the Six important quality attributes which are operational. Okay, during operation of your embedded system, what type of quality attribute the system should have or the system should possess. So this is all about the quality attributes of an embedded systems. Now moving further, the non-operational quality attributes. Which are the non-quality attributes? That is testability and debugging ability, evolvability, portability, time to prototype and market, per unit and total cost. So wherein if you just observe the terminologies, it nowhere concerned for my operation of the embedded systems. Does the cost of the system, will it make any sense on embedded system that is in the operation? No, definitely not. Take an example of filling up the ghee. Now, filling up the ghee, and is there a cost? Does it make anything here? For the embedded system I'm talking. Does it make any changes for the embedded system that is currently working? Definitely not. That's what we call it as non-operational quality attributes, which are not in function, which are not the points which are not related to functioning of the embedded systems, which are related to non-functioning of the embedded systems. Now let us go through one by one. We'll finish it very quickly. Probably another 5-6 minutes. We'll finish these important points. Now coming to testability and debugging. What do you mean by testability? For any of the embedded system or product that you consider, testability is applicable for both hardware as well as software. Which means that whenever I design an embedded system hardware, I should ensure that the whether my interfacing ports are working or not, right, before getting into market. Okay, because once it is delivered to the market, so I cannot, if I start receiving any complaints on my hardware or software algorithm, then it is a black mark for the embedded engineers. So hence, first important non-operational quality attribute is testing the devices. Now, which and that particular testing may be in testing with algorithmic testing. That's what embedded firmware we are talking about, or it may be ensuring the peripheral ports, and which is related to embedded hardware testing. So these two are very important in terms of hardware testing, right? Testing of the device. Now, what do you mean by debug? Now, you have a debug session. See, I have a LPC 2148 ARM processor. Now, I will be trying to download the program onto the hardware. So for which, before downloading, I will be always going for debugging my software or debugging my algorithm whether it is syntactically correct or not. So that's where whenever I design any of the hardware, say for example LPC 2148, accordingly equivalently debugger should be developed or it must be developed. And same thing is true if I develop a FPGA hardware, then equivalent debugger called ISC simulator, integrated simulation environment, that is once again a debugger we call it as, then it must be developed. Same thing is true if I develop a 8051 microcontroller, equivalent debugger must be present. So these are the two important aspects of the embedded systems. That is, one is at debugging at hardware level and debugging at the firmware level, right? So that's where in a VLSI engineering system there is one separate team called design for testing, DFT engineers we call them as. The job of those DFT means design for testing or design under test. So these engineers job is whether the hardware developed is working for all the conditions of various temperature levels, various voltage level. They have supposed, and for all possible input combinations, whether my device is working or not. So that's what we call about hardware level debugging. And coming to firmware level debugging, okay, I try to give the software for the particular hardware, whether that particular software will able to cope up with the hardware and operating system or not. So that's what the firmware level debugging. No, evolvability. The name itself indicates evolution. Comes with a biology terminology from the biology. Evolution is nothing but which is not inherent, which is not the from the blood, or which is not the person who is not from the heritable. So non-heritable variation, anything that is, you can consider that a mutation, change that is occurring in the embedded system. So with respect to embedded system, evolvability refers to is with the embedded product, which is nothing but a modified program or modified hardware. Say for example, I try to come up with a new product in an embedded system. So it should if I write a new algorithm tomorrow, if I have a one hardware. Now today I try to download one of the program, then assume that there is a EEPROM, and I try to arrest that algorithm and try to install one more algorithm, or I try to modify that particular algorithm, then whether my hardware should able to sustain or digest that particular change or it should not, then definitely it has to non-heritable, and it has to be accept the modifications that whatever the design engineers perform. So that's about the another non-operational quality of an quality attribute of an embedded systems. Next is portability, a very important point. So which is nothing but which relates to system independence. What do you mean by system independence? So uh, irrespective of the hardware that we have, the whatever the change in the program, the system should be able to give me the output. Say for example, I try to give a very easy example here. So okay, before to that, let me read a statement here. An embedded product is said to be portable if product is capable of functioning as such in various environments and different target processor, different target controllers, and different operating systems. Okay, now considering an example here, so I try to write an embedded firmware. What do you mean by firmware? Which is nothing but a software. Say for example, I have some instructions to be given to processor. Say for example, divide by 0 is one instructions that I want to give. Whenever their algorithms runs for divide by 0, then it's an exception case. Automatically the processor should state that the irrelevant input as such automatically, because any hardware you develop, this feature must be there in any of the hardware, right. Now that's where I try to write a such equivalent firmware for an embedded system, and assume that I try to install that same software. Now this is the embedded firmware. I try to write and I download it onto the 8086 processor. Now I take the same firmware and now I try to download it onto the second ARM Cortex M3 processor. Now, well, due to if there is a minor changes, yes, obviously the migration is best thing that's what can happen, because I try to reduce lot of time in writing separate firmware for two different hardwares. The same firmware can be used for a multiple target processors, is it not? Because here if I write it in a C language, that could be a more portability, I call it as. The portability is easy because C language is a universal language, I call. Now assume that if I use 8086 instruction set to write the firmware, okay, to write the firmware, if I use 8086 assembly instruction, then again, is it possible for me to download same firmware software on ARM Cortex M3? Definitely it is not possible. Now, such firmware, embedded firmware, I call them as a non-portable firmwares. So this is a very simple thing, then how you are supposed to understand the portability of embedded systems design. Okay, I hope you understood here. Now, giving another super example, see here, Microsoft developed the Visual C++. Visual C++. Okay, now if I want to use this Visual C++, if I don't have Microsoft OS, okay, then definitely it is not possible to run this Visual C++ if I change my target hardware operating system in apart from any other Windows. Apart from the Windows, it is not possible to run VC. Right? It is not possible for you guys to run this Visual C++ on Ubuntu OS. Oh no, this is not a portable software. That is what developed by the uh, Microsoft. So same thing. Android is a portable OS because it suits on any of the hardware developed by either the hardware may be developed by Samsung or Oppo or even HTC, right? Or even the even by from the Google mobile phones. Okay. Now, is that the same thing is true with Apple? Because no, because they developed the separate Mac OS, which is more suitable, not only suitable to the hardwares of Apple. Now, I call that it is a non-portability, right? Again, the another very important the application called Java. Java is one application where it performs many jobs, maybe in right from constructing the website to handling the database. So this is a Java which is we call it as independent of a system. Why? It can be either run on Microsoft OS, either run on Macintosh OS. So you can Sun developed by the Sun microsystem works on any of the operating system. Okay, so same thing is not true with Visual C++. So you can able to remember all these good examples so that you can understand the meaning of portability. Now, the last two important points. Okay, we'll wind up this topic now. Time to prototype and market. See, whenever we asked you to design in your project, we asked you to design the prototype. What do you mean by prototype? A small working model. Okay, small working model, not actually the commercialized hardware. It is just a working model. Say for example, you might have designed the filth segregator, where that filth job of that filth segregator is to separate the what we say that uh, uh, segregation of waste which are wet and which are dry waste and wet waste. ಒಣ ಕಸ ಮತ್ತು ಹಸಿ ಕಸ ಎರಡು ಸಪರೇಟ್ ಮಾಡುವಂತಹ ಒಂದು ಫಿಲ್ತ್ ಸೆಗ್ರಿಗೇಟರ್ ಎಂಬೆಡೆಡ್ ಸಿಸ್ಟಮ್ಸ್ ಡೆವಲಪ್ಮೆಂಟ್ ಮಾಡಿದ್ದೀರಾ ಅನ್ಕೊಳ್ರಿ. ಸೊ ಪೀಪಲ್ ವಿಲ್ ಗೋ ಅಂಡ್ ಪುಟ್ ಇನ್ ಅ ಒನ್ machine, and based on the sensors it has to sense whether it is a wet waste or whether it is a dry waste. Now, before commercializing these types of products, now students perform this as a prototype. So they have to understand which are the hardwares required, which are the sensors are required to sense wet and to sense dry waste, and they are supposed to require to work on what is the cost that it may occur to develop a prototype, and of course how much duration it takes to develop this particular prototype, right? So before to the market, the students will have to go for conceptualized product development and before it is ready for selling. So that's what we call it as the prototype development. So if the prototype development is faster, then of course we can able to calculate the actual estimated time. Okay, now what do you mean by time to market? Here two terms. One is time to prototype and time to market. Okay, once you are done with a prototype development, then you must make sure that or ensure that it has to be in the on time. Because if you don't do it, some other your competitor may do it, is it not? So it is very important, whenever you develop a product, make sure ensure that before any other person comes to the market, you have released that product onto the market. So that's what the important topic about non-operational quality attribute. Whenever a embedded system engineer, whatever you remember till now, it's immaterial, but this point you must remember. You must, because no one will be waiting for you to give the because the people are if whenever the a new product appears to the market, so the people are very eager. So unless you lose that particular market, then your product will go waste. When to release, that's very important point. So, and yes, of course, change in the market, we have to adapt for the change. The very good example, guys, I'll tell you. Take an example of Nokia phones during the era of between 99 almost okay to in the beginning of 2003 and between 2000 almost till almost 11 I can consider. This is the era of Nokia. So whichever the phone they release, it is going to hit in the market. Definitely, it used to compete with many of the its on par competitors, and it used to hit the market. And but later on, why the Nokia failed? The only reason is adaptability, change in the technology. They don't wanted to change their software. So I'm sorry, right now I don't remember that the software that operating system that Nokia people had in those days. If you have, if you know, you can put it in chat room. I don't remember right now. But when Android started, when no, Samsung started looking onto the or moving on to the Android, and they become hit. They could hit the market like anything when Samsung Ace came into existence. Because and then they also came up with a new model called by combining with Microsoft called Nokia Lumia, where which was consisting of Microsoft OS in Nokia mobile phones. It got failed because of the easy user interface. It was not so easy user interface as compared to Android. Okay, Android, so initially WhatsApp used to supported by the Android at the first time, but WhatsApp when it came, it was not supporting in Microsoft OS. Later on, once again they modified that OS, and then once again they released the updated version. By that time they lost the market. So this is the history of Nokia, where they could not able to adapt for the change in the technology, and adaptability was the issue. That's where we call it as somewhere else. It's also a point of time to market, right? Time to develop the prototype. Try to understand the emotions of the users, emotions of the people, emotions of the buyers. So unless you analyze and understand the need of an user, and ನಂಗೆ ತಿಳಿದದ್ದ ನಾ ಮಾಡ್ತೀನಿ ಅಂತಂದ್ರೆ, then probably we lose the market. So this is how the other things. Accordingly, the change in the students generation, probably there must be also a change in the faculty in handling the students. That's what we call it as here also time to market, right? That's where another very important point here, uh, per unit cost. Okay, this is very important, guys. Per unit cost and revenue. Yes, of course. When you design a single unit, the cost of that product will be differed. When you design the same product in 100 in numbers, once again there is a cost is going to be differed. Per unit cost will going to be differed, and accordingly based on your cost, the revenue of the company is going to be dependent. So obviously if you try to develop at the very cheaper cost, there might be a cases of failure in the market because of the quality of, probably sometimes we are compromising with the quality. So very important point, without compromising in the quality, we have to give a best market price. So that's where cost is the factor which is closely monitored by both end user and the product manufacturer. The end user always try to use the lowest cost with the highest quality. The product manufacturer always try to keep up the products at the higher rate, because else he will be at the loss. So this is a big trade off between buyer and the manufacturer. So that's what I told. Any failure in the position of the cost commercial product at the nominal rate may lead to the failure of the product in the market also, because probably the company may be on the quality issue. So that's where proper market study and cost benefit analysis should be, it must be carried out before taking the decision about per unit cost. Okay, whenever I want to release to the market, then I should analyze, and I should analyze what my equivalent competitor is doing and how he is able to get benefit out of it, then at what price I should release my product. Now this is the last concept of this day, product life cycle, PLC. Okay, there is one more recently a coin called platin coin, we call it as a PLC. I think you know it. It is just like a Bitcoin, which is a cryptocurrency. PLC anta ಒಂದು ಹೊಸದು cryptocurrency ಕೂಡನು ಇದೆ. In that way you can remember the product life cycle. Now what is this product life cycle? Now the product life cycle is nothing but a graphical representation of what? Of unit cost, of the product sales, of the profit with respect to the time period versus revenue generated. Which means you can observe here, what if you observe what you will understand by looking into the diagram. So as the time increases, as the time increases, initially look at the growth of the product. The growth of the product increases. Now as it increases, similarly initially the product, assume that it is at very low, less numbers in sales, the unit cost is at very high rate. Okay, and if you look at the profit at the initial days, it is in the negative, almost. Now as the sales increases, per unit cost also decreasing and profit margin also increasing. As the time still increases, look at this, the very important point, at one particular time when the revenue is at highest, when the company's revenue at the highest for a particular embedded product, assume that a mobile phone itself, okay, when the company revenue is at the peak, then it is to be understood that the product come to an maturity, and probably then there is a decline in that particular product and we have to move for the new product. It is something like the same thing is true with the human life. You can able to see this as the time increases at one particular time. So initial days around till less than 20, we have no revenue, no profit, nothing. After that, we start working somewhere else between 20 or more than 20 up to, you can consider, to 40 or 45. And after 45, once again our revenue also decreases as we are in the retirement stage, right? The same thing is true for any product to consider. Okay, so initially the product sales of any embedded system you consider, it will be very less, and profit will be in a negative. The unit cost will be at the higher range. As you increase the product sales, the revenue increases, profit margin also increases, per unit cost also decreases. But at one point of time, the sales will go for saturation region, and then onwards it starts downwards. Now at this peak, definitely if you look at the revenue of the particular company will be at the higher range. Now what they do, they stop that particular product and they will give the new product in a newer version, right? So same thing, if you look at the 10 years old, the Tata company used to release only vehicles like Tata Indica, Tata Zest, Tata Just kind of vehicles, Tata Indigo. Now all those products are not there in the product market. They released a new one. The same thing is true with many other companies also. You can just take any company and analyze. So this is what we call as product life cycle of an embedded systems. So with this, we will complete the this particular topic called characteristics and quality attribute of the embedded systems. That is chapter 3 from your KB Shibu. Okay, so let me stop, and if you have any doubts, let me know. And before to that, I have just one question for you. Note it down and tell me answer in the tomorrow's class. Okay, the mean time between the failure MTBF is of an embedded system is equal to 4 months. Okay, then mean time to repair MTTAR is 2 weeks. Then what is the availability of the product in terms of percentage? So that is AI you need to calculate. I hope you know the formula for this. Put it and try to calculate the availability in terms of percentage. Okay, any doubts? We'll come back to the chat room. Is there any doubts that we discussed in this class? Are you listening to the class or simply turning on the Google Meet and keeping aside your device? Okay, fine. Thank you. Any doubts? Okay, regarding I'm receiving few messages on the quiz that we have conducted, because after updating the answers, I could the Excel sheet did not update it. Probably that's the reason why your marks with in the Excel sheet might not be matching. Don't worry. Once again, I'll make corrections and I'll regenerate the updated Excel sheet. I do it and I'll forward the updated Excel sheet also. Okay, not to be worried. Anything apart from that you have doubt, let me know. Else we'll leave the meet. Tomorrow we'll meet at 9 a.m. Okay. So for for second internals, the syllabus is so for first year, first internals we kept up till arithmetic instructions. Now from there up to whatever we complete till this weekend. Okay. Probably I also posted the timetable of your second internals in our WhatsApp group. Go through that, and probably the day after tomorrow is my last class. Till there, the syllabus will be there for your second internal as a second internal portion. Okay, take care. I will meet once again tomorrow at 9 a.m. Thank you.